In this section, we will review solving linear inequalities, and we are going to talk about something new called interval notation. In the past, we have talked about inequality notation. Here we would say that x is greater than or equal to 5. Notice that the alligator, you think about that inequality symbol as being like an alligator's mouth, the alligator will eat the larger portion. So we want to basically shade all portions of the graph where x is greater than or equal to 5. So when I go to graph this, we're going to draw our number line. Here's our 5. And if we look up above, if we use an equal sign on our inequality symbol, then we will use a closed circle when we graph. All this means is that the boundary point itself is included as a possible value for x. Now we want to shade all of the x values that represents values that are greater than or equal to 5. Well, where are values greater than 5? That would be toward the right. Now in interval notation does not have any variables in it. It does not have an inequality symbol in it. All we have to do first is write the smaller value on the left. Now if you look at your graph, what's the smallest value represented on that graph? Well, that would be 5. Put a comma. And what would be the largest value represented on that graph? Well, we notice that it's pointing toward positive infinity. It never stops. So the largest value represented would be positive infinity. Now how do we say that 5 had a closed circle on my graph? What we're going to do is, if we have a closed circle on my graph, then we're going to use a bracket, closed bracket there next to the 5. Infinity is always parentheses. We never can actually include infinity as a solution. As a concept, infinity goes on forever, so we will put an open parentheses always next to infinity. Solving an inequality. If you could solve an equation, you can solve an inequality. To solve an inequality, we're going to follow similar rules. We will first use the distributive property to eliminate all parentheses, and then we will combine like terms on either side of our inequality separately. Then we will use the additive property. We want to get all the x terms on one side, constants on the other. Then we will either multiply or divide to get x by itself. Remember that if you multiply or divide by a negative number, then you flip your inequality symbol. Our goal, if we have one inequality symbol, is to get x by itself on one side of that inequality symbol. If we have a compound inequality where we have two inequality symbols, then our goal will be to get x by itself in the middle of those two inequality symbols. Let's look at our first example. We want to solve the inequality and we want to write our final answer in our interval notation. Solving for x. We have one inequality symbol. Since we only have one inequality symbol, our goal is to get x by itself on one side. And I recommend getting x by itself on the left-hand side when you're doing inequalities. So what do I want to do first? Let's subtract 1 from both sides of our inequality. Combining like terms here, we get minus 8 minus 1, we have minus 9. And then let's get that x by itself on the left-hand side. In order to do that, we would subtract 2x from both sides of our inequality. 3x is less than or equal to negative 9. The last thing that we want to do is divide by 3 to get x completely alone. Our solution becomes x is less than or equal to negative 3. Notice that I did not flip my inequality symbol. We only flip the inequality symbol when I divide or multiply by a negative number. Here I divided rather by a positive 3, so my inequality symbol does not need to flip. This is what we would call our solution in inequality form. What we want to also do is be able to graph this solution and give our answer in interval notation. So let's go ahead and graph it. We have our -3. We want to use a closed circle because we have an equal sign here. Put a closed circle on my -3. And then we notice that the alligator this time is eating the -3. So that must mean x is smaller. We want to shade the portions of the graph where x is smaller than -3. So I will shade the portion of the graph to the left of -3. The last thing we want to do is write our answer in interval notation. Interval notation says we put the smallest value represented on my graph toward the left. Now my arrow on the left here is pointing toward the left toward -infinity. So I have -infinity, comma, the value on the very right of my graph will be the largest value represented, and that would be -3. Parentheses always next to infinity, and because I used a closed circle and I had an equal sign on my inequality, all of those things mean that I should put a closed bracket next to my -3. This is my final answer, -infinity to -3, open parentheses on infinity, close bracket on -3. Doing the graph first really helps to give you that interval notation. Alright, in this example we once again have one inequality symbol. So our goal is to get x by itself and a number on the other side. The first thing I want to do is get rid of my parentheses by doing a distribution. We have two sets of parentheses, so we'll go ahead and distribute on both sides there. 5 times x is 5x. 5 times -2 is -10. Then we'll also distribute our -7 into the second set of parentheses. -7 times x is -7x. -7 times a +1 would be a -7. So the first thing we want to do is distribute to clear out our parentheses. The next thing we want to do is we want to combine our like terms on each side to make each side look as simple as possible. What are my like terms on the right hand side of my inequality symbol? Well, that would be 5x and -7x. That would be a -2x. -10, -7, -17. We have now combined all the like terms on each side of the inequality symbol separately. Now we want to get x by itself on one side. I recommend getting x by itself on the left hand side. Go ahead and add 2x to both sides. That gives me -2x plus 3 less than -17. Don't forget your inequality symbol. Now we need to subtract 3 from both sides. Now on the left hand side we only have -2x less than -20 on the right hand side. The last thing we want to do is divide by -2. Now remember that when I divide by a negative number, our inequality symbol has to flip. So we have x is greater than a negative divided by a negative is a positive. So we have +10. This is our inequality. We want to go all the way to interval notation. So let's draw our graph first. Put our number line with 10 in the middle. And this time I do not have an equal sign, so I'll use an open circle on the 10. And x is greater than, the alligator is eating the x, so this x must be larger. We want to shade all of the x values that are larger than 10. So we will shade the portion of the number line that is larger than 10. And of course our arrow is pointing toward the right forever, which is +infinity. So my interval notation will be from 10 that's the smallest value represented on my graph, to the largest value, which would be positive infinity. Because I have an open circle, we will use open parentheses. And we use open parentheses on both. And this would be my final answer in interval notation. Now in this problem we have fractions. I have a denominator of 5 and a denominator of 4. The trick to getting rid of our fractions is to multiply through by the LCD of all of the fractions. 2 of our values don't look like fractions, so I'm going to put them over 1 to keep in mind that they can be thought of as fractions with a denominator of 1. So what is the LCD of 1, 5, 4, and 1? Well, that would be 20. Our strategy is to get rid of the fractions at the beginning by multiplying everything by 20. All of the terms on the left-hand side of the inequality symbol and on the right-hand side. Now you can think about that as 20 over 1 to keep in mind that 20 is thought of as the numerator and 1 is thought of as the denominator, so that when we do the multiplication of our fractions, we know what gets multiplied times what. So we have 20 times negative 2, that would be negative 40. 20 times 1/5, well, we do top times the top, and then bottom times the bottom. Don't forget our x. Greater than or equal to, now we're going to do 20 times 1/4, top times the top is 20, bottom times the bottom is 4, don't forget your x, minus 20 times negative 3 would be negative 60. Now the whole point is that our denominators should divide evenly into our numerators. So let's reduce those fractions. 5 goes into 24 times. 4 goes into 25 times. And now we have no fractions in our problem. Much, much easier to solve. Let's get our x values on one side of the equation, or inequality. Minus 5x minus 5x. And let's add 40 to both sides. So now we have negative x, our 40s have canceled, negative x greater than or equal to negative 60 plus 40 would be negative 20. The last thing we want to do is divide by minus 1. Since we're dividing by a negative number, we do need to flip our inequality symbol. So that would be positive x less than or equal to positive 20. Let's draw our graph. Draw our number line with 20 in the middle. Closed circle or open circle. Well, since we have the equal sign, we will use a closed circle on 20. And we want x values that are less than or equal to 20. So where are x values less than 20? Well, we want to shade toward the left where x values are smaller. And of course that's pointing toward negative infinity. So our interval notation would be the portion on the left of my number line, the smaller portion, negative infinity, all the way to 20. Open parentheses always on infinity, and since we had a closed circle and an equal sign, in interval notation, that means we need to use a closed square bracket. And that would be our final answer in interval notation. Here we have another problem with fractions. Once again, we want to identify the LCD of all of our fractions and multiply all the way through by that LCD. You notice this time we have two inequality symbols, and so our goal eventually will be to get x by itself in the middle. But let's get rid of our fractions first by multiplying everything through by the LCD, which would be 6. So we'll multiply here by 6 over 1, and here by 6 over 1, and here by 6 over 1. Now, instead of just multiplying the 6 in, let's use our reduction property that says that if we are multiplying two fractions together, if we notice that there are common factors on the top and the bottom, then we can cancel those before we actually do the multiplication. We have a 6 here and a 6 here, those are common, and that leaves me with minus 5 over 1, but we don't need the 1 as our denominator, less than 3 goes into 6 twice. Since I have a 2 that's being multiplied times a binomial, I will have to distribute here. 2 times 2x will give me 4x, and 2 times a positive 5 will give me a positive 10. Less than or equal to, and here on this side we can also cancel out our 6's, and I end up with a positive 5. Now our goal here is to get x by itself in the middle, so we attack the middle. First, we want to get rid of the number 10, so we're going to subtract 10. If you do something to the middle to get x by itself, you have to do the same thing to the outer two parts. So we have negative 15 less than 4x less than or equal to negative 5. The last thing that we want to do is to divide by 4. That'll give me x by itself in the middle, but if I divide by 4 in the middle, I have to divide by 4 also on the outer two edges. So our answer is negative 15 over 4 less than x less than or equal to negative 5 over 4. We're going to draw our number line. This time I have a smallest value of negative 15 over 4 and a largest value of negative 5 over 4. We'll just go ahead and draw those on our number line. And less than, no equal sign next to the negative 15 over 4, so we'll use an open circle on the left. We have an equal sign on the right, so we use a closed circle on the right. And notice that x is in between the two, so we will shade all of the x values in between the two. In our interval notation, once again, it looks almost exactly like the graph. We put our smallest value on the right, comma, smallest value on the left, comma, largest value on the right. It should look exactly like your number line. And do I need to use an open parentheses or a square bracket, closed square bracket? Well, this one has an open circle, so we put our parentheses. And on the right-hand side, we have a closed circle, so we will use our closed square bracket. Remember, it's always smallest on the left, comma, largest on the right. Alright, last problem. We do not have any fractions on this one. So all we want to pay attention to is that we have two inequality symbols. Two inequality symbols means that we want to have x by itself in the middle of two numbers. And we want to attack the middle first to make this happen. Do whatever it takes to the middle to get x by itself. So the first thing we're going to do is we're going to subtract 1. That gives me negative 4 less than or equal to negative 3x less than or equal to negative 3. And then I want to divide by negative 3. Now what happens when we divide by a negative number? Our inequality symbols have to flip. So we're going to simplify and flip our inequality symbols. Negative 4 divided by negative 3, that's a positive 4/3. Flip our symbol, greater than or equal to. In the middle, our negative 3's cancel, so we're left with just x. Greater than or equal to negative 3 divided by negative 3. Anything divided by itself is always 1. Now we want to be careful, if our inequality symbols flip, we want to be careful that we put the smallest on the left. Notice that the alligator is eating the 4/3 and also the x, so this must be the smallest portion now, and this must be the largest portion. So when we go to graph them, we will put the smallest on the left, largest on the right, and in this they both have equal signs on them, so they both have closed circles, and x is in between, so we shade everything in between those two boundary points. So our interval notation will be smallest on the left, largest on the right, close brackets on both because they both had closed circles. Now let's say that you did not know that 4/3 was actually the largest and was larger than 1. You can always take that improper fraction and convert it to a mixed number. 3 goes into 4 one time. 1 times 3 is 3. So this actually gives us the mixed number 1 and 1/3. So we know that 4/3 would actually be larger than 1 because 4/3 is the same thing as 1 and 1/3, which obviously is larger than 1. So if you have an improper fraction, you want to convert that to a mixed number just to see where to place it on the number line.